Last question of this section asks us to repeat the example that I've shown below with two cranes supporting a one-ton beam in static equilibrium, and the direction angles are 45 degrees and 120 degrees respectively, and I want to round to the nearest pound. So I'm going to update the drawing below with the information they just gave us. Here is the updated drawing with the beam that is 2,000 pounds and the angle measures. We were given that T2 had an angle measure of 120 degrees, but that's from 0. And so from the y-axis line, it's actually 30 degrees because this angle is 120 degrees minus 90 degrees. That's why you see the 30 there. We want to find the magnitudes of the tension vectors, T1 and T2, to the nearest pound. So we need to do some calculations here and figure out what is going on. Because the beam is in static equilibrium, then the sum of all of the vectors that have force are equal to 0. That's what equilibrium means. Now, we have 3 different vectors that we're talking about. We have tension vector 1, tension vector 2, and the vector W, which is the beam. All 3 of those have to sum to 0. Static equilibrium, again, is the 0 vector. That's why there's a vector symbol over it. And so tension 1 vector and tension 2 vector and the W beam vector must sum to the 0 vector, which means that both I and J have coefficients of 0. Remember that a vector is found by taking the magnitude times cosine theta I plus the magnitude times sine theta J. Let's write all of this out with the information that we're given. So T1 is going to be given by taking the magnitude of T1 times the cosine of theta 1 times I plus the magnitude of T1 times the sine of theta 1 times J. T2 is going to be equal to the magnitude of T2 times the cosine of theta 2 times I plus T2 times the sine of theta 2 J. W is already equal to negative 2000 J. Adding these together, we get magnitude of T1 times cosine 45I plus magnitude of T1 sine 45J plus magnitude T2 times cosine 120I plus magnitude T2 sine 120J plus negative 2000J has to equal 0I plus 0J. And remember, theta 1 was 45 degrees because that was the angle for T1, and theta 2 was 120 degrees because that was the angle for theta 2. Our goal is to find the magnitudes, and right now we have the cosines we can evaluate, the sines we can evaluate. We can equate the I portions together and the J portions together. Let's evaluate the degree measures. I know that the cosine and sine of 45 degrees are both root 2 over 2 from the unit circle. The cosine of 120 is negative 1/2, and the sine of 120 is root 3 over 2. I'm going to group the i's together now. I have an I term here, and an I term here, and an I term here. The nice thing about this is I can, first of all, clear the i's by dividing every term by I. But I can also multiply everything by 2 to get rid of the denominators. The 2's will cancel in the denominator because 2 times root 2 over 2 is just root 2. 2 times negative 1/2 is just negative 1. And 0 times 2 is 0. So right now I have root 2 times the magnitude of t1 minus the magnitude of t2 equals 0, or adding the magnitude of t2 to both sides, I have root 2 times the magnitude of t1 equals the magnitude of t2. Now let's equate the j terms. We get the square root of 2 over 2j times the magnitude of t1 plus the square root of 3 over 2j times the magnitude of t2 minus 2000j equals 0j. I can divide through by j as I did with the i's. I can also multiply by 2. 2 times root 2 over 2 again is just root 2. 2 times root 3 over 2 is just root 3. 2 times 2000 is 4000, and 2 times 0 is 0. I'm going to add 4000 to both sides. And now I know that t2's magnitude is equal to root 2 times t1. And so I'm going to substitute in to the equation root 2 magnitude of t1 right here for t2. Root 3 times root 2 is root 6, which then gives me root 2 times the magnitude of t1 plus root 6 times the magnitude of t1 is equal to 4000. And I'm going to factor out t1 to solve for t1's magnitude. So I'm going to factor the t1 magnitude out, and I'm left with root 2 plus root 6, which I can then divide through on both sides. I try and keep it as exact as possible. I don't like to turn into decimals until I absolutely have to. When I take 4000 divided by the sum of root 2 plus root 6, I get that the magnitude of T1 is roughly 1,035 pounds. Recall that the square root of 2 times the magnitude of T1 is equal to the magnitude of T2. And I'm going to substitute in that 1,035 pounds to get T2. £1,464 is equal to the magnitude of T2.